Hey guys, Mr. Riz here to help you out with the 2-2. Here we go. What we're going to be looking at is solving absolute value equations. Now, the notes say and inequalities, but for our class, guys, we're just sticking with equations here. All right, so what we want to do here, in a little warm up, we want to find the distance between each point and zero on the number line. So how far away is each point from here to here? Go ahead, pause the video, go and see if you guys can answer these questions. All right, now let's check our work here. So if we look, all right, A is 3. So we're at -3. We are 1, 2, 3 spaces away. B is 5 spaces away from 0. All right, C is also 3 spaces away from 0. D is 1.5. E is 2.5. And F is 8.1. If you notice anything about all these answers are all positive. They are all a distance of positive units away from 0. Okay, and that's going to lead to absolute value, where we're looking at things that are always positive. All right, here's our state standards. Big thing that you guys are going to be able to do by the end of this is solve equations and using absolute value algebraically. All right, so solving absolute value equations algebraically. The absolute value of a number is the distance from 0 on the number line. So the definition of an absolute value can be used to solve equations that contain absolute expressions by constructing two cases. Basically, the case is going to be for any real numbers a and b. If the absolute value of a is equal to b, then b has to be greater than or equal to 0, so b is a positive number. Then a equals b or a equals negative b. So we get a positive and negative version of the answers. So one thing we want to do here when we're solving is basically follow these 4 steps. Is first thing we got to do is isolate the absolute value expression. So we want to get the entire expression by itself, okay, on one side. Then once we do that, we're going to split up into 2 problems. We're going to write 2 cases. We use the properties of equalities. We solve normally. And then the last thing we must do here is to check our solution. That's going to be really key for this section here. All right, because sometimes absolute values may have 1, 2, or no solutions. So an absolute value that has 1 solution if the problem does not meet the constraints of that problem. So this answer is known as an extraneous solution. Okay. An absolute value could potentially have no solution or any answer that works, even though we get 2 numbers at the end. When we check, it might not work, and that's called an empty set. And we either use that by an empty bracket here as set builder notation, or we use the empty set symbol. All right, so let's go through, solve this problem here, and kind of work with this. So the first thing we want to do is to isolate that absolute value. Okay, let me go through and get my pen set up here. Here we go. All right, so we got 2 times the absolute value of 5x plus 1 minus 9 is equal to 4x plus 17. Okay, so what we need to do is to isolate the absolute value. We're going to add 9 over to the other side. We have 2 times the absolute value of x plus 1 is equal to 4x, and that'd be what, plus 26. And then the next step we want to do is divide by 2. We're going to divide both sides by 2. So we're not going to do anything with the absolute value here. But we are going to divide 4x by 2, that's 2x, and 26 by 2 is 13. Okay, so now what we need to do here is to split this up into 2 cases. So we have 2 cases here. The first case is just straight up 5x plus 1 is equal to 2x plus 13. Normal math stuff. It didn't change, okay? If we are x, the absolute value of x is 5, x could be 5. The other thing here, and this might be a technique or we might do a shortcut, is what we're going to do here is make 5x plus 1 is equal to the opposite of that, the opposite of 2x plus 13. Now, technically, that just becomes a 5x plus 1 is equal to a negative 2x minus 13. So we're going to do the complete opposite. So now that we have these 2 separate problems, we're going to split that up and solve each one individually. So we minus the 2x over here, we get 3x plus 1 is equal to 13, minus the 1, 3x would equal 12. If we divide by 3, we get one solution of x equals 4. On the other side here, we're going to do the same thing, except for we're going to add 2x over. 7x plus 1 is equal to negative 13. Minus the 1, we get 7x is equal to negative 14. Divide by 7, we get x equals negative 2. So here is an example where we can have two solutions. Just double check this here. What we want to do is to then make sure, clear off my drawing here, we're going through and checking those two answers. So if we plug in 4 into the original equation, it's the absolute value of 5 times 4 plus 1 minus 9 equal to 4 times 4 plus 17. Plug that in. Okay, that's 21. The absolute value of 21 is 21. Times that by 2 is 42. If we subtract 9, that's 33. All right, over here, 4 times 4 is 16. 16 plus 17 is 33, so that's true. Now, if we use negative 2, 5 times negative 2 is negative 10, plus 1 is negative 9. The absolute value of negative 9 is positive 9. We times that by 2, that's 18. 18 minus 9 is 9. A lot of 9s going on there. On the other side, 4 times negative 2 is negative 8. Negative 8 plus 17 is a positive 9. So both answers work, and we're going to write this as the solution set of 4 comma negative 2. You could put it either order here, negative 2 comma 4. That's fine as well. All right, so go ahead, pause the video, give this one a try. No, we're going to try it in just a second. All right, let's see how well we do here. So what we need to do is isolate this first. So we're going to add the 6 over to the other side. And we get absolute value of 5x minus 3 is equal to negative 2x plus 18. All right, we need to then break this up into two separate problems. Okay, so I'm going to make one problem. That is just 5x minus 3 is equal to negative 2x plus 18. Then I'm going to go over here on the other side and make a complete opposite one of 5x minus 3 is equal to a positive 2x minus 18. All right, let's work on the easy one first. So we're going to add 2x over to the other side. 7x minus 3 is equal to 18. We add 3 over to 18. We get 7x is equal to 21. Divide, we get x equals 3. Now over here, we're going to minus the 2x over this time. 3x minus 3 is equal to negative 18. Add 3 over. 3x would equal negative 15. And divide by 3, negative 5. All right, so we get our two answers. What we need to do then is to check. So we're going to plug these numbers back into the original equation. So the first one, absolute value of 5 times 3 minus 6, does that equal negative 2 times 3 plus 12? All right, let's see. The 5 times 3 is 15. 15 minus 3 is 12. So absolute value of 12 is 12 minus 6. Okay, that's 6. Now over here, we'd get negative 2 times 3 is negative 6 plus 12. That would be 6. Okay, that works. So that's definitely is an answer. Let's check with negative 5. Absolute value of 5 times negative 5 minus 3 minus 6. Does that equal negative 2 times negative 5 plus 12? Running out of room. Here we go. All right. So we'd get, let's see, negative 5 times 5 is negative 25 minus 3. That's negative 28. The absolute value of negative 28 is a positive 28. If we subtract 6, that's 22. Now over here, negative 2 times negative 5 is a positive 10. If we add 12 to that, it's 22. So yes, both those numbers work and both tries. There's our solution set. We would say our solution is 3 and negative 5. Okay. There we go, 3 and negative 5. There's our graph. Give this another try here. Let's see if you guys can handle it. Pause it. Let's check your work. Okay, here we go. So we need to isolate it. So I'm going to add the x over to the other side. So 2 times absolute value of x plus 1 equals 4x minus 4. Next, we'll divide by 2, and we get the absolute value of x plus 1 is equal to, if I divide both sides by 2, that becomes a 2x minus 2. Sorry for my handwriting here. That's what it is. All right. All right, so now we need to make our two cases. One is x plus 1 is equal to 2x minus 2. And the other case is the opposite. X plus 1 is equal to a negative 2x plus 2. First one here, I'm going to minus the x over. 1 is equal to x minus 2. Add 2 over to 1. 3 would equal x, or x would equal 3. Now over here, I'm going to add the 2x over because that's smaller. 3x minus 1 is equal to 2. Minus the 1, or add the 1. 3x would equal 3. Divide x would equal 1. All right, we want to check our solution. So we're going to plug it back into the original equation. So does 2 times the absolute value of 3 plus 1 minus 3, is that the same thing as 3 times 3 minus 4? All right, so we get 2 times the absolute value of 4 minus 3. That's 8 minus 3, and that would be 5. Now on the other side, 3 times 3 is 9. 9 minus 4 is 5. So yep, 5 does equal 5. That works. Now with 1 here, did I do that right? I gotta make sure. With 1, we double check. Does 2 times the absolute value of 1 plus 1 minus 1 equal 3 times 1 minus 4? So that's 2 times the absolute value of 2. That'd be 4. 4 minus 1 is 3. Now on this side here, yeah, did I do that right? I'm double check. This is where I need to kind of double check. I'm getting worried because 3 times 1 is 3. 3 minus 4 is negative 1. 3 does not equal negative 1. Did I mess up with my work here? All right, we make the complete opposite. Negative 2x plus 2. And we would add 2 over, that's 3. We minus the 1 over, that's, or add 1 over, that's 3. Okay, that does not work. So our solution is just 3. Let's check our answer here. Is that what the computer tells us? All right, so yeah, when we plug it in, it does not equal. So the only solution that works is 3. All right, once again, let's try to solve this one here. Try it on your own. Pause the video. Let's see if you guys can handle this. All right, let's check our work. So we got to isolate. So we need to minus the 10 over first. We get an absolute value of 4x minus 7 is equal to negative 8. Then we're going to break it up into our two problems. We get 4x minus 7 is equal to negative 8. Leave it alone. Then another one of 4x minus 7 equals the complete opposite, positive 8. Let's solve both of those. All right, if I add 7 over to there, we get 4x is equal to negative 1. Divide, we get negative 0.25, we'll say. All right, here we're going to add 7 over to 8. 4x would equal to 15, and divide x would equal 3.75. Now, just because they're decimals doesn't mean we messed up, but we still need to check here. All right, if we plug this in, the absolute value of 4 times negative 0.25 minus 7 plus 10, does that equal, plus 10, does that equal 2? So let's see, that's going to be the absolute value of negative 4 times, that's negative 1 minus 7. That'd be the absolute value of negative 8. The absolute value of negative 8 is positive 8, and 8 plus 10 is 18, not 2. Okay, so that did not work. Let's check with positive 3.5. So 4 times 3.75 minus 7 plus 10, does that equal 2? 3, so that's what, 12 plus 3, so that's 15 minus 7 plus 10. That would be absolute value of 8. Absolute value of 8 is just 8. And 8 plus 10 is 18, not 2 again. So this is an example where no solution can actually work out. We can actually kind of tell that right away. When we isolate the absolute value and we get equals a negative number, remember, it can never equal a negative number. It's always going to be a positive thing. We have no solution. Okay, so why don't you guys pause this video, give this a try. Try these problems here. All right, when you guys are ready, unpause the video and we'll check our answers. All right, so first one here, when you isolate and split, you only get one solution, you should get 6. All right, next one, when you isolate, you got to minus the 1 over, then divide by 3, then split them up. Make the opposites there. You get 2 answers, 15 and 1. Number C, very similar. You're going to add the 18 over, do the absolute value, split up into 2 problems, plug them both in, check, it works. And last one, D, even though it's long and scary, it doesn't mean it's going to be anything mean. You're going to minus the 3x, divide by a negative 5, split it up, end up getting 2 answers that don't work. Okay, so we're going to skip the inequalities, and that's pretty much what we got going over here today. So thank you guys for watching. If you have any questions, make sure you ask, but good luck on the CYU, and I will see you guys later. Have a great one.